All right, this is number 29, and what we're going to need to do is we're going to set up to solve for angle A. Now, angle A is your unknown, so what's going to go on the left side of your equation? 8 squared, okay, because it's got to be the side opposite the angle that you're trying to solve for. So you have a squared, then I just go ahead and grab up the other two numbers. Now once I've done that, it's easy to finish out the equation, because then you go, oh, it's minus 2 times this number times this number times the cosine of the angle opposite that, so angle A, kind of running out of space there. Okay, so what you're going to do, you're going to do these out with your calculator, so that's going to be a 64. Then I'm going to do that next, so I'm going to go 18 squared plus 24 squared, which is going to give me 900, minus, then I'm going to do those three numbers right there, 2 times 18 times 24, and that's going to give me, that doesn't seem right, hold on. I guess I did it. Okay, 864 times the cosine of angle A. Because the 864 is multiplied by the cosine of angle A, I have to get rid of this part first. Okay, so I've got 64 minus 900. That's how I get it to the other side. So I have negative 836 is equal to negative 864 times the cosine of angle A. Now, that is multiplied by the cosine of angle A, so to get rid of something that's multiplied, you have to divide. So I'm going to divide both sides by negative 864. If I want to, I could go ahead and get a decimal value for that. But you know ultimately what you're doing is angle A is equal to the inverse cosine of 836 divided by 864. I probably would just go ahead and do that. Okay, inverse cosine of 836 divided by 864 is going to give me approximately 14.6 degrees. Okay, that is angle A. Now, at that point, I would switch and do law of sines. You don't have to. If you are one that really likes law of cosines, you can keep going. You can do the same thing, but do it with B. Okay, personally, I believe law of sines is easier. So I'm going to go 8 over the sine of 14.6. I'm going to go ahead and find B next. So 24 over the sine of angle B. I'm going to cross product, so I have 8 times the sine of angle B. Now that's your unknown right there is angle B, so you know that you're going to use inverse eventually. 24 times the sine of 14.6. Now to get rid of the 8, I'm going to have to divide. So ultimately, my angle B is equal to the inverse sine of 24 times the sine of 14.6. Now understand the calculator is going to put a parenthesis there. Go ahead and close your parenthesis, divide it by 8, and then put a final parenthesis. Okay, don't forget to do that. So inverse sine of 24 times the sine of 14.6, closing parenthesis, divided by 8, and then another parenthesis. And it's going to give me 49.1. Now, how would you find angle C?
Subtract from 180.
I would. Now, you don't have to do it that way. If you want to do it the hard way, go ahead and do either law of cosines or law of sines again. But 180 minus 49.1 minus 14.6 is going to give me 116.3. Now, obviously, that's not drawn scale because that angle is not 116 degrees. But I always draw out my triangle just so I can see how each side is related. Okay? Does that make sense? Okay, so that finishes that section right there, which is the last section in the chapter. So pick up your study guide. I think you're going to find that you use this material all the way through, so it's pretty set in your head. Okay, at the very beginning of the chapter, we started with the basic foundation of what sine is, what cosine is, what tangent is, what cosecant, secant, and cotangent are. And so what they would do is they would give you a triangle, and they would go, oh, name the 6 trig functions of this theta, or this angle. So, on that, hold on 1 second, let me get there. Okay, so they might give you something that looks like this. The cosine of theta is equal to 2 over 15. They give you that. And they go, okay, find the other 5 remaining trig functions, and you can make them in fractions. They might tell you if you're going to make them into a decimal or round it to 4 places after the decimal. Just pay attention to the instructions. If I have a cosine, I need to remember that phrase, okay? SOHCAHTOA, that's going to help you. At least I think it will help you. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. I feel like at this point, you probably have those pretty memorized, okay? We've used them over and over again. So if I'm talking about cosine, I'm going to draw out a triangle. Now remember, I'm going back to when I had right angles. Okay, this was right at the beginning of the chapter. These are right triangles. So let's just say that's going to be my theta. My theta is where I'm going to stand. So I'm standing right here. If I say the cosine is 2 over 15, that means adjacent over hypotenuse. 2 is adjacent, hypotenuse is 15. We do understand why that's the adjacent side, right? Okay, I've got to find the third side to find the rest. How do I find the third side?
Pythagorean theorem.
Pythagorean theorem. Now, this is a leg and this is a leg. So that's your unknown right there. Okay, so you're going to have 2 squared plus x squared is equal to 15 squared. When you work backwards, you've got 15 squared minus your 2 squared. And that's going to give me x squared is equal to 221. What am I going to get when I take the square root of 221? Y'all remember? Okay, I don't know if it comes out even or not. 14.9. Okay, it's going to be somewhere in that ballpark. So we'll round it to 14.9. You could leave it as just the square root of 121 and break it down if you want. Or 221. So you could probably, I'm trying to think what you could divide that by. I wonder if you could make it into anything. Let's just do a decimal value. That's why they were going to tell you to round it to to 4 places afterwards, so that you didn't leave it with a decimal and a fraction. Okay? So now I come back over here. I've got sine of theta. I'm actually going to go ahead and do the cosine of theta and the tangent of theta. Okay, now this is the one that they gave you. This would be the cosecant of theta, because that's the inverse of the sine. This would be the secant of theta, and this would be the cotangent of theta. Now, I've got this one, 2 over 15. Now, let me change colors so you can see it. I can make that into a decimal value. Just go 2 divided by 15, and I'm talking about 0.1333. That's rounded to 4 places after the decimal. All right, if I'm talking about sine, I'm talking about 14.9 over 15. But I cannot leave it like that because I can't have a decimal or fraction. So 14.9 divided by 15, I'm going to have 0.9933. Tangent, opposite over adjacent. So 14.9 over 2 is going to give me 7.45. Okay, you with me so far? Now remember, to get this one, I'm going to flip it. So 15 divided by 14.9 is going to give me 1.0067. This one, I'm going to flip that. So I'm going to have 15 divided by 2, which of course is 7.5. And this one, I'm going to flip that one. So 2 divided by 14.9. So 0.1342. Y'all remember how to do all that? Okay. I'm gonna give you one to try, okay? I'm gonna give you one trig function, and I want you to give me the other 5, okay? I will leave all this up here. All right, the sine of theta is equal to 3/4. Find the rest of them. And round it to 4 places after the decimal value. Okay, after the decimal, so in other words, they don't leave it as a fraction. I will probably go ahead and do it up here while y'all are doing it there. So don't look up here unless you really have to. See if you can do it on your own. You get them? Which ones? Did you get the fact that this was the square root of 7? Okay, did you round that there? Did you go ahead and get a decimal value for that? Okay, if you did, are your things real close? Not really? Because if you rounded there at the beginning, that might explain some of it. I would say you're pretty close. I'd say it was the rounding on that square root of 7, okay? Now, here's the deal, guys. You don't even have to make it into a decimal. If you leave it as a fraction, just make sure that you remember that you can't have a square root on the bottom of a fraction. So you literally could have left this as 3 on the square root of 7 over 7 if you wanted, okay? Or get a decimal value for it. Now, what Callie did was she got a decimal value for the square root of 7, which made her answers a little bit different than mine. But when you're talking about 0.6615, the fact that I think you had 0.65 or something like that, that's not much, okay? It was a difference in the rounding, okay? And I'll make sure that I look at that. Okay, we good on this? All right, moving on to the next section. They actually asked you, actually it's still 13.1, and they would give you values and you'd have to solve for the rest of the triangle, okay? So I'm going to give you one of those to do. Again, it's making sure that you understand that stuff, okay? Except for at the very beginning of this chapter, you really didn't use all 6 of them. Let's say, now again, these are still right triangles, so you're not using law of sines and law of cosines. That's not until the end of the chapter when you don't have right angles. So let's say I have this. And I know that little c is 16, and I know that little a is 7. Go ahead and solve the rest of that triangle using trig.
I think my camera shut off.
Did it? Oh, no, it's still going.
I heard a look
You heard a click. It's got about 3 minutes left. Now understand, you're solving the triangle. You're not finding sine, cosine, and tangent. Not like you just did. Make sure on those on the test that you pay attention to where they tell you to round it. If they don't tell you, go ahead and always round it to the tens. Okay? We're good on that? Okay. Let me restart this camera.